name is Samuel Chukwuemeka. In this video session, we shall discuss difference quotient, and we shall solve some problems on a difference quotient. Let's talk about what we mean by difference quotient. Let's recall if we have 2 points on a rectangular coordinate system. That is your graph, okay, 2-dimensional coordinate system. Okay, your y-axis and your x-axis. So let's say we have 2 points on this graph, right? Let's say we have a point A, okay, and a point B. So let's say that point A is x and f of x. Okay, point A is x and f of x. And then let's say we have an incremental change. If we have an incremental change here, h, such that point B will be x plus h, and then f of x plus h. Okay, point B is your x plus h and f of x plus h. Okay, so we have these 2 points now on this system. Okay, and we have a curve. Let's say we have these points on a curve of y equal to f of x. Okay, now from your definition of slope, you see that the slope m is delta y over delta x, which is a change in y over change in x. Okay, change in y over change in x. Now, this is pronounced as this is a delta. Delta is not an English word. It's a Greek word. It's a Greek alphabet. Not Greek alphabet. Okay, so your slope will now be y2 minus y1 over x2 minus x1. In this case, the slope of AB, of the line joining points AB, if we refer to that slope of the line joining points AB, okay, and this line is known as the secant line. So that slope will now be delta y, change in y, which is f of x plus h minus f of x, okay, all over change in x plus h minus x. So this h, like we said, is an incremental change in x. Some textbooks refer to it as delta x. It's an incremental change in x. Okay, so we now have that this slope will be f of x plus h minus f of x all over h, because x minus x is 0. Okay, now the slope of this line is what we call the difference quotient. The slope of the second line is what we refer to as the difference quotient. Okay, now what is the meaning of all this that I did? This difference quotient is what you use in calculus to find your derivative. Actually, when if you find the limit of this function as h tends to 0, that gives you your derivative. Okay, that gives you your derivative. And the process we will use here to find the difference quotient is like it will prepare you for to know how to use the first principle, finding the derivative of functions using first principle in calculus. So this is very important in calculus. If we have the limit of this function f of x plus h minus f of x over h, as h tends to 0, I am saying tends to h tends to 0, tends to 0. Now some textbooks will write h approaches 0. Okay, so don't be confused. Okay, tends to approaches. Okay, so this limit will now be, as it tends to 0, this will now be your dy dx, which is your derivative. Now, this is the slope of the line tangent to the curve at the point A. Okay, so this is like, gives you like a variation of the slope formula, finding the slope, and when you find the limit of that slope as h tends to 0, it gives you your derivative, the definition of your derivative function. Okay, and also we said that it prepares you for knowing how to find the derivative of functions from first principle, that is in calculus. So that is basically what the difference quotient is all about. Remember, we said that the difference quotient, I'm going to write it here, that the difference quotient is your f of x plus h minus f of x all over h. Okay, I will also recommend that before you view this video, that you have viewed the videos on operations on functions, under relations and functions. This topic is under relations and functions. All right, so we have a question 1. Question 1, f of x is equal to 5x plus 4. So we want to find, we are using this formula, and it is, this is not difficult at all. It is not. They gave us f of x, and they want us to find the difference quotient of these functions. So you have f of x already. So go ahead and find f of x plus h. So when we did evaluating functions, yeah, that is the video you need to view. Evaluating functions, yeah. Then you also view operations on functions. Evaluating functions and the operations on functions. It is important. So this means that we replace x with x plus h. So this is 5 times x plus h plus 4. And this will give us 5x plus 5h plus 4. So we now have that f of x plus h minus f of x all over h will now be 5x plus 5h plus 4, that is what we have here, minus f of x. You put your parentheses because this is an entity. You've got to put your parentheses there, it's an entity. Okay? All over h. So this will now be 5x plus 5h plus 4 minus 5x minus 4. If you distribute that all over h. And then 5x minus 5x, that is gone. 4 minus 4, that is gone. So you now have 5h over h, and that will give you 5, because h will cancel h, and you have 5. Question 2, f of x is 2 minus x. So we go ahead and we find f of x plus h, and that will give us 2 minus x plus h. Because wherever we see x, we put x plus h. So this will give us what? 2 minus x minus h. So the difference quotient will be f of x plus h minus f of x, all divided by h will be 2 minus x minus h minus f of x is, you put the parentheses, 2 minus x. This is where some students make mistake. Here. They don't put the parentheses. If you do not put it, it will give you a wrong answer. It will give you an incorrect answer. So please, don't make that mistake. Okay? All divided by h. So this will be 2 minus x minus h minus 2 plus x. Okay? All divided by h. And this will be 2 minus 2 is gone. Minus x plus x is gone. And now I am left with minus h over h. H divided by h, and I have negative 1 as my answer. The difference quotient is negative 1. Right? I am going to put the calculator for finding this on my website. I will put the calculator for finding this on my website under resources, so you can check your answer using that calculator. But I hope you understand how to do it. Yeah. As usual, my website is Samuel, www.samuelchukwuemeka.com. Okay. Or you just type my name on Google or Bing, and you see my website. Okay. Question 3. We have that f of x is negative x squared plus 7x minus 8. And I will solve, we have 10 questions here. I will solve varieties. Okay, so we now have f of x plus h. Like I said earlier, this will prepare you to solve the derivative of functions. First derivative of functions from first principle. From first principle means from the definition. Yeah. This prepares you to do that. Okay? Yeah. So f of x plus h, like, and how will you know whether you're correct? That reminds me. If you're familiar with calculus already, if you differentiate that function, it gives you 5. Okay? Although, you know, the differential, the derivative is the limit as the h tends to 0. So, but we don't even have h here. Yeah, and even if we take the limit as h tends to 0, it is 5. Now, the difference quotient is not the derivative. It is just the limit of that. It's just the derivative is the limit of the difference quotient as h tends to 0. H is the incremental x, delta x, incremental change in x. That is h. Some textbooks write it as delta x. That is what it means. In the case whereby you don't see h as the answer in the answer, that also gives you your derivative of this function if you are taking calculus. Okay. Now, f of x plus h will be negative x plus h all squared. You have to be careful here. Plus 7 times x plus h minus a. So this will be what now? Negative, I'm going to put this, okay, so let me break this down. Let me break it down. Plus 7x plus 7h minus a. And this will be negative. We have x squared plus 2xh, because it's xh plus xh. 2xh plus h squared plus 7x plus 7h minus a. And that will give us a negative x squared minus 2xh minus h squared plus 7x plus 7h minus a. Right? So this is our f of x plus h. So let's go ahead and let us find the difference quotient. This will give us what now? Minus x squared minus 2x minus h squared plus 7x plus 7h minus a. Minus, I put my parentheses, alright, minus x squared plus 7x minus a, right, all over h. Okay. So what am I going to get now? Let me continue from here. This will now be equal to minus x squared minus 2xh minus h squared plus 7x plus 7h minus 8. Now this is now plus x squared minus 7x plus 8 all over h. And this will now be minus x squared plus x squared, gone. 7x minus 7x, gone. Minus 8 plus 8, gone. What do I have now? Minus 2xh minus h squared plus 7h all over h. And that will give me h is common. h is common here. h is common. So is the GCF. Factor by GCF. Factor by GCF. This will be negative 2x minus h. Okay, plus 7 all over h. So h divides h. So your answer becomes negative 2x minus h plus 7. And then if you take the limit as h tends to 0, it will be minus 2x plus 7. Okay, minus 2x plus 7. That is differentiation or the derivative, first derivative from first principle. If you look at this now and take it from second principle or by the rules of differentiation, you see that this is minus 2x plus 7. Yeah. But in the difference quotient, we have to put this also. Yeah. Now the limit as h tends to 0 gives you the derivative. Okay. I'm sorry if I am introducing calculus here. That is the relationship here. Okay. Let's go ahead and solve question 4. We will, after solving question 5, we will stop the video so that we will continue the second video from question 6 to the remaining 10. So next one is question 4. F of x is 8 minus 3x squared. We find f of x plus h, and that is 8 minus 3 x plus h all squared. So this will give you 8 minus 3, and you have to be careful, fix that first. X plus h times x plus h. And that will give you 8 minus 3, x squared plus 2xh plus h squared. And that will give you 8 minus 3x squared minus 6xh minus 3h squared. Right? So we now see that f of the difference quotient, f of x plus h minus f of x all over h will be 8 minus 3x squared minus 6xh minus 3h squared minus, you put your parentheses, 8 minus 3x squared all over h. So you now have that this is equal to 8 minus 3x squared minus 6xh minus 3h squared minus 8 plus 3x squared all over h. And this will be 8 minus 8 is gone, minus 3x squared plus 3x squared is gone. So I have minus 6xh minus 3h squared all over h. Factor by GCF, factor the numerator by GCF, greatest common factor. That will be h minus 6x minus 3h, right? All over h. H divides h, that. And this will be minus 6x minus 3h. And this becomes the constant. Now, let's check this. If you find the limit, if you find the limit of this as h tends to 0, it will be minus 6x minus 3 times 0, which is minus 6x. If you use the rule of differentiation and differentiate this function, it will be 0 minus 6x, and that will just be minus 6x. So the difference quotient, you can actually know whether you got it right if you know differentiation or differential calculus. When you find your difference quotient, find the limit as h tends to 0 and find it, and then also differentiate this function from second principle or with the rules of differentiation, and then if it gives you the same thing, then your difference quotient is correct. That's a way to check whether your difference quotient is correct. But that means you will know calculus. All right, let's solve the fifth one. Question 5. We have f of x is equal to 5x squared minus x minus 12. Okay? If we differentiate this using second principle, it's going to give us 10x minus 1. Okay? To give us 10x minus 1. Okay. So whatever we find as the difference quotient, if we take that limit as h tends to 0, it gives us this. Alright, let's do that. F of x plus h will be 5x plus h all squared minus x plus h minus 12. So this will be 5. We've done this before, at least twice now. So this is x squared plus 2xh plus h squared minus x minus h minus 12. Right? So we have 5x squared plus 10xh plus 5h squared minus x minus h minus 12. Right? So we now have that our difference quotient, f of x plus h minus f of x, all divided by h is equal to 5x squared plus 10xh plus 5h squared minus x minus h minus 12 minus parentheses 5x squared minus x minus 12 all divided by h. Okay? I hope you are understanding it. Alright, let's continue. I've got to put a smile on your face because some of you might say, oh, wow, that's a lie. So when you do this kind of question, you smile a bit and then you continue. Alright, so this will be equal to 5x squared plus 10xh plus 5h squared minus x minus h minus 12 minus, you know what, I've got to use this whole stuff. Minus 5x squared, I'm distributing distributive property, distributing negative 1. Minus 5x squared plus x plus 12 all over h. And this will now be what? 5x squared minus 5x squared gone. Minus x plus x gone. Minus 12 plus 12 gone. So what do we have left? We now have 10xh plus 5h squared minus h all over h. Then we factor the numerator by GCF. Factor by GCF. This is h, 10x plus 5h minus 1 all over h. Bam, bam. Done. And you now have 10x plus 5h minus 1. This becomes your answer. Now when you find the limit as h tends to 0, this will be 10x plus 5 times 0 minus 1, which is now 10x minus 1. 10x minus 1. All right. Let's do the last one in this video session. Question 6. Question 6. F of x is x cubed minus x squared plus 2x minus 1. Now that's a log, cubic function. Alright, so f of x plus h will be x plus h all cubed minus x plus h all squared plus 2 times x plus h minus 1. Okay, let's take it gradually. So this will be, let's have this. We already know that this is a, do you want me to use Pascal's triangle? Because that will save me time, honestly. That will save me time to use Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. But just, hey, you can do this on your, do this on your own. I just want to use Pascal's triangle here. Okay? But go ahead and do this on your own. If I use Pascal's triangle, I have x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay? Right. Then minus, I have here x squared plus 2xh plus h squared. Then plus 2x plus 2h minus 1. Okay? So, let me finish this up. This will be x cubed plus 3x squared h plus 3xh squared plus h cubed minus x squared minus 2xh. Okay? Minus h squared plus 2x plus 2h minus 1. So this will give me what now? No, I don't think anything will cross out. So let's look at it again. Usually nothing crosses out at this point. If you notice something crosses out at when we now subtract f of x plus h minus f of x. That is where we see things crossing out. But usually at this point, nothing crosses out. I am just double checking. All right, let's finish this stuff. Let's finish it. Please do this on your own, just to save time. That was why I used Pascal's triangle. Now this will be x cubed. Okay, we've got this f(x plus h). We now have f(x plus h) minus f of x all over h will be x cubed plus 3x squared h plus 3x h squared plus h cubed, right? Minus x squared minus 2xh minus h squared plus 2x plus 2h minus 1 minus parenthesis, okay, minus parenthesis. This is x cubed minus x squared plus 2x minus 1, all divided by h. So this will be equal to x cubed plus 3x squared h plus 3x h squared plus h cubed minus x squared minus 2xh minus h squared plus 2x plus 2h minus 1 minus x cubed plus x squared minus 2x plus 1. Hey, when you're dealing with this, look at a good thing you should do. Count how many times here to make sure that we do not skip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are good on that. And this other one is 4 times. 4 times. Okay. All over h. And so we now have x cubed minus x cubed gone. Minus x squared plus x squared gone. Plus 2x minus 2x gone. Minus 1 plus 1 gone. So what do we have remaining? 3x squared h plus 3x h squared plus h cubed minus 2xh minus h squared plus 2h all over h. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So factor by DCF, h, 3x squared plus 3xh plus h squared minus 2x minus h plus 2 all over h. H cancels h. Bam, bam, bam. And what do you have? What do you have? What do you have? Okay, can I just write what I have here? My answer is now 3x squared plus 3xh plus h squared minus 2x minus h plus 2. This is my answer. Okay, so if I differentiate this from second principle, it will give me 3x squared minus 2x plus 2. If I find the limit of this, as h tends to 0. This will be 0, this will be 0, this will be 0. So I will have 3x squared minus 2x plus 2. Yay! Alright, in the second video, we shall solve fractions. Okay, difference quotient involving fractions. So you may need to view the second video. Alright, thank you so much for this.